This video is about the line and a plane. Given line L, R equals A plus lambda B, and plane pi, AX plus BY plus CZ equals D. We know the normal vector equals ABC. There are three situations for a line and a plane. Intersect at some point, like this. This is L, this is a pi. Intersect at this point, P. Then we can figure out the coordinates of this P. Let's label the angle between normal vector n of the plane pi and the direction vector B of L as phi. The angle between the line and the plane, let's label as theta. From the diagram, we do know phi plus theta equals 90 degrees. So phi equals 90 degrees minus theta. Cosine phi equals cosine 90 degrees minus theta. This is a cofunction formula equals sine theta. Remember this formula. Cosine phi equals sine theta. Since phi is the angle between normal vector of the plane and the direction vector of L, cosine phi equals vector n dot vector B over length of n times the length of B. So we have this formula. When the line is parallel to the plane, vector B is perpendicular to vector n, which means vector B dot vector n equals 0. No intersection. What if the line is on the plane? Vector B perpendicular to vector n, and a common point or infinite intersection points between the line and the plane. In this situation, assume vector A is A1, A2, A3. Then A1 plus B(A2) plus C(A3) equals D. The plane pi1 has equation 3x minus y plus z equals negative 13. And the line L has a vector equation this. Lambda is all real numbers. Given that L meets pi1 at the point P, find the coordinates of P. Let's draw the diagram first. This is the plane pi1. We have a line intersect this plane at P. First of all, we will change the equation of line into parametric form. X equals 1 minus 3 lambda. Y equals 2 minus lambda. Z equals negative 2 plus 4 lambda. Therefore, the coordinates of P are 1 minus 3 lambda, 2 minus lambda, and negative 2 plus 4 lambda. Since P is on the plane, we will substitute the coordinates for x, y, z in this equation of the plane. So we get 3 times 1 minus 3 lambda minus 2 minus lambda plus negative 2 plus 4 lambda equals negative 13. Distributive property 3 minus 9 lambda minus 2 plus lambda minus 2 plus 4 lambda equals negative 13. Combine like terms. Negative 4 lambda minus 1 equals negative 13. Negative 4 lambda equals negative 12. Lambda equals 3. Then we plug back to the coordinates of P. P, 1 minus 3 times 3, negative 8. 2 minus 3, negative 1. Negative 2 plus 4 times 3, 10. Let's go to B. Let theta be the acute angle between the line and the plane pi 1. Find the cosine theta. This is a B. Normal vector. This is a phi. This is a theta. We do know sine theta equals cosine phi equals n dot b, length of n times the length of b. Normal vector 3, negative 1, 1. Dot. Vector b is a direction vector here. Negative 3, negative 1, 4. Square root 3 square plus negative 1 square plus 1 square times the square root negative 3 square plus negative 1 square plus 4 square. Work this out. 3 times negative 3 plus negative 1 times negative 1 plus 1 times 4. Denominator 9 plus 1 plus 1, square root of 11 times 9 plus 1 plus 16, square root 26 equals negative 4, square root 286. Since theta be the acute angle, let's make an absolute value here. Equals 4 over square root 286. Therefore, for cosine theta equals, using the formula sine square theta plus cosine square theta equals 1, cosine theta equals square root 1 minus 4 over square root 286 square. Simplify. Square root 270 over square root 286. 3 square root of 30 over square root 286.